So hello guys, how are you all? I hope you all are doing fine. In the previous lecture we finished off our game theory. So in this lecture we are going to start a new unit, that is unit 1 according to your syllabus, that is general equilibrium. Okay, and market failure is also there, but we will go to market failure later. So we are starting with general equilibrium now. So first of all, we know what is partial equilibrium. So partial equilibrium is the study of behavior of individual decision making units and market. Okay, so, according to Alfred Marshall, who developed the partial equilibrium analysis, price and quantity in each market is determined by the demand and supply curve drawn on the ceteris paribus assumption. This is important. That earlier what you were doing, that if I write down general equilibrium model, so we are going to study about 2 into 2 into 2 model. This is also known as 2 into 2 into 2 model. Okay, because we consider here two goods X and Y, two factors labor and capital, and two consumers A and B. So in the partial equilibrium, if we are taking this market, goods market, we won't consider the factors market. Okay, so this will be doing in the partial equilibrium. Like if we are seeing from consumer point of view, we will only see from his point of view. We won't take the production into figure. Okay guys, so but what will we do, that in the partial analysis basically ignores the interdependence amongst the market. Like if I am seeing this market, I will be making these two markets ceteris paribus, like which is constant. I won't take this into consideration and I will keep this as a constant. So earlier, from now you will study general equilibrium, and before that you were only studying the partial equilibrium. Okay, so which you were studying till now was the partial equilibrium, and now we will study the general equilibrium. And okay, so what was the reason behind the partial equilibrium theory? So according to Marshall, methodology is largely self-contained and independent of other markets. Okay, so this was the basic which Marshall told about doing partial equilibrium analysis. But after that some new analysis come, that is general equilibrium analysis, and it was developed by Leonie Walras, which was the economist, and you can also remember this from Sunny Leone. Okay guys, so what does it do? So it studies the behavior of all individual decision making units and all individual markets. Okay, it take consideration of all the market unit, that it take condition, or I won't say market unit, individual decision making unit, right, and all individual markets. So he is in the general equilibrium model, he is taking all individual decision making units also and all individual markets also in the consideration while determining the equilibrium quantity and price and whatever we will be discussing afterwards. And this all happens simultaneously. Earlier what we were doing, that we were putting them as a constant, we were taking constant if we are taking one, but now we will take all into consideration simultaneously. Okay, so general equilibrium is more comprehensive as compared to partial equilibrium, as interrelationship amongst market explicitly taken into account. Obviously it's a comprehensive model because we take all the market into consideration, but earlier we were using the assumption of ceteris paribus, which is all other factors keeping constant. Okay, so both the models are important, and it basically depends upon the issue being investigated, like the issue which you are investigated. So you have to determine according to your issue which model is best for you. So okay, this was the introduction. So now we will start our general equilibrium model, so which is also known as 2 into 2 into 2 model, because we have here two goods, two factors, two goods X and Y, two factors labor and capital, and two consumers A and B. Okay, so now there are some assumptions of this 2 into 2 into 2 model or general equilibrium model. Okay, so what is the first assumption? First assumption is that two factors of production, that is L and K, labor and capital, and whose quantities are exogenously given. Okay, so these are not endogenous, these are exogenously given, and also they are homogeneous and perfectly divisible. So this is our first assumption. It's easy. Another assumption, there are two commodities X and Y. So the production of two commodities are shown by the two isoquant maps showing diminishing MRTS and constant return to scale. So again, there are two commodities X and Y, and the production function of two commodities are shown by two isoquant map. And you know what is isoquant? That gives the different level of input that provides you the same level of output. Okay, because it is just the replica of the what you studied in consumer theory, that it is just the replica of the your indifference curve. Okay, so okay, this was a second assumption I am writing here, CRS. It is following constant return to scale and diminishing MRTS. Okay guys, so let's move on. So the third assumption is that, obviously it will be about consumer now. There are two consumers, A and B, and their preferences are shown by IC, which is downward sloping and convex to origin. Downward and convex. Okay, so this is our third assumption. Okay, so let's move on to the next assumption now. So the fourth assumption is that the goal of each consumer is the utility maximization. Utility maximization subject to income constraint. Okay, so this is also easy. And similarly, goal of each firm is profit maximization subject to technological constraint. Okay, so now we will see the sixth assumption. So the sixth assumption is that the factors of production are owned by consumer A and B. That will be their endowment. Factors of production owned by consumer A and B. Okay, and the seventh assumption is that there is full employment in factors of production and all income received by their owners are spent. So that means, in short, I can write that there is no savings. Okay, so now there is a last assumption, and what is the last assumption is that there is perfect competition in factors and goods market. That is, price of X, price of Y, W and R all are given and remain unchanged. So you can write perfect competition. I'm just writing in short, but you should read it full and learn also. Okay, Actually, there is nothing to learn in this. It's easy, and it was basic also. You already knew it. Okay, so these were the 8 assumptions which we will follow while doing this model. Okay. So now I will tell you the condition of general equilibrium model. We have done the introduction and assumption. So now we will see the condition. What are the condition for the general equilibrium model? So first condition is that equilibrium in production. What does it mean? It means that efficient allocation of factors between two firms. Okay. Second is equilibrium in consumption. What means? It means that the efficient allocation of commodity between two consumers. Easy. And the third one is simultaneous equilibrium of production and consumption of first and second one. So there should be simultaneous condition, equilibrium of production and consumption simultaneously. Okay. So now if these three conditions are fulfilled, what do we call it? Now it is called that Pareto efficient condition, which I was telling you in the game theory that I will going to tell you afterwards. So here comes the time, and these three static properties are called Pareto efficient conditions, given by Italian economist Vilfredo Pareto. Okay, so combining these three, if anything satisfy these three properties, so it will be considered as Pareto efficient. Also we can say it as Pareto efficient condition. So now our basic is over, so we will take one by one, first this, second this, and then we club these two so that we get this. So now we are first going into equilibrium in production. Okay guys, so equilibrium in production. So as you know that equilibrium in production requires the determination of efficient distribution of available productive factors among existing firm. Okay, so a firm is in equilibrium if it chooses the factor combination which minimizes its costs in case of one commodity. So equilibrium in production is given by, and this you have already done also, that when you know that when the slope of isocurrent is equal to slope of isocost line, so you can directly write slope of isoquant is equal to slope of isocost line. So if you remember, what is the slope of isoquant? If you remember, it is MRTS, marginal rate of technical substitution. And what is the slope of isocost line? It is the ratio of price of labor and the price of capital. So PL upon PK. Okay. Or there was one condition also, if you remember, or it was just the same only, but we will write it in a different manner. What is MRTS? MRTS is the ratio of marginal productivity of labor and MPK, right? And what is price of labor? Price of labor is wages, which is denoted by W. And what is price of capital? What we get from capital is rent. Okay, so these are the opportunity cost of labor and capital. Okay, but this condition is only applicable for one good, but we are studying general equilibrium model, so there will be joint equilibrium condition. So what will be joint equilibrium condition in this case? There will be MRTS of good X and MRTS of good Y is equal to P by L, which will be same in both the case. So this is your final condition of equilibrium in production. Got it guys? So now we will draw the Edgeworth box of production. Edgeworth box of production. Okay guys, so now first of all I tell you what is the Edgeworth box. So when you were taking the only one good earlier, how you used to draw the graph? Like if I'm drawing for X, so I'll take here labor, here capital, and these are the isoquant curve. Okay, and so it is for X. If there will be a isocost line, so you will get this quantity, this amount of labor and this amount of capital for the X good. Similarly, if you want to draw for Y, you will do the same thing. Okay, there will be different isoquant for Y. So what Edgeworth boxes do, if you rotate this one and do it like this, so here will be OY, if you can imagine. So basically it is this. So I am rotating this and joining with this. So it will be OY and it will be OX, origin of Y and origin of X, right? And there will be labor and capital this side, and for Y similarly if you rotate, so here it will be labor and here it will be capital. Okay guys, fine till now. So there will be many isoquant curves for X which will be like this, and we assume that it will be convex. Similarly there will be many for Y which is like this. If you rotate this whole curve, it will be like this. Okay, so let us name the quantity which will be going to produce. So this will be x1, x2, x3, x4, x5. Similarly for Y, you can write here y1, y2, y3, y4 and y5. It is for this one. Okay, so any point on Edgeworth box tells you about the 6 thing. So what are the 6 things? So let's see what are the 6 things. Okay, so first thing is that quantity of X produced. So at this point, what is the quantity of X produced? If you can see here, it is X4. So first thing we see the quantity of X produced. Similarly, the second thing at this point will be the quantity of Y produced. The quantity of Y produced is Y2, corresponding to this point. Okay. Third is that the quantity of labor used in production of good X. So this will be the point LX. You know the quantity of labor used in production of good X. Total good is X4. And fourth is the quantity of labor used in production of good Y, which will be here. Okay. Similarly, you know the fifth part is that you know the quantity of capital used in produce for good Y, good X, and similarly the sixth is for good Y. So these are the 6 things which you get to know in any Edgeworth box. Okay guys, so now let's move on further. So now we will see whether there is input efficiency or not. So I'll again draw one Edgeworth box. I'll take few isoquant curve so that it won't get messy this time. So I'm taking 3 only. 1, 2, 3. Okay. So similarly for Y, 1, 2, 3. We can write it as x1, x2, x3, y1, y2, y3. Okay. So now if I take this point here, so we have to see that whether it is an efficient point or not. So how do we know about the efficiency? Okay, so first of all the points in the box are not efficient combination of available factor. It is not necessary that every point in the box will be the efficient combination of available factor. So given the labor and capital, the effective is to produce the maximum possible output. So the efficient level will be that level which is the maximum possible output that you can produce with the given labor and capital. Okay. So if produced combination of x and y is such that it is impossible to increase the production of one commodity without decreasing the production of another commodity. So this is basically called Pareto efficiency or input efficiency. So if I see this point, so is it Pareto efficient? So it's obviously not Pareto efficient, and also I can tell you one thing, that whenever there is lens occurring, you can see here lens is there, here lens is there, so it is not, it is the intersection of this won't be Pareto efficient. So they are not producing the Pareto efficient output. Okay, so now how do we know that, how can we know that we can increase one by keeping the other constant? So what you can do is, like, you can draw one more here. Okay, this is the isoquant and this will be greater than x2, so that is, let us name as x2 dash. Okay, so now here what I have done is, I have taken the another isoquant which is x2 dash, and I have increased from x2 to x2 dash without decreasing the production of y2. Okay, so if you see that I have increased the production of one good without decreasing the production of the other. So at this point it was not Pareto efficient because we have scope to increase the consumption of either one good. Similarly, you can also take for y also. You can draw y here, or I'm just taking for the x. Similarly, you can do for y also. So there will be only one point where the slope of isoquant of y and slope of isoquant of x will be same. That point will be Pareto efficient, because this point is Pareto efficient because there is no scope for increasing the production of one good without keeping in consideration the decreasing of other good. Okay, so whenever there is a lens occurring, so that means there is no Pareto efficiency. Also here you can see that MRTS x is not equal to MRTS of y. So there will be Pareto efficiency only where MRTS x is equal to MRTS of y, which I have already told you. Okay. So now I draw the third Edgeworth box. In this I will take all the Pareto efficient point. So first I am drawing for x 1, 2, 3, 4. And similarly I am drawing for y such that MRTS of x and MRTS of y is same. Okay, so these were the Pareto efficient point in your Edgeworth box, and if you join these point, what you will get? You will get contract curve. So what you can say now, what is contract curve now? So the locus of point of tangency of x and y isoquant, as you can see, is called the contract curve. Okay, so this is the basically the locus of the Pareto efficient combination of labor and capital between the firm. Okay, so now we will introduce the concept of production possibility curve. So from here we are only seeing that at this input level, these input levels are Pareto efficient, but we don't know that how much are they. So it will be known by what is the technological constraint you have. So that will be shown by the PPC. Okay guys, so you already know that PPC is derived from mapping of the production contract curve from input space into an output space. Okay, so and each point on the contract curve and PPC describe an efficiently produced level of x and y. So PPC shows various combination of x and y that an economy can produce by fully utilizing all of its labor and capital with the best technology available. So what will be the condition? The slope of PPC is marginal rate of transformation, which we already know that, and which is equal to MCX upon MCY. Okay, as there is perfect competition in both the goods market, so the equilibrium production must fulfill the condition of MRT is equal to price of X upon price of Y. Okay, so now guys, I have already written you the condition so that we don't waste our time. So what will be the equilibrium condition for good X? You already know it's a perfect competition, so it will be MC equal to price. So P of X, Px is equal to MCX. Similarly for Y, Py is equal to MCY. So now if you divide 1 by 2, you will get Px upon Py is equal to MCX upon MCY. And we already know that what is this? This is the slope of PVC, which is marginal rate of transformation. So I have drawn this PPC here, taking good X on the X-axis and good Y on the Y-axis. So I have taken the PPC. So similarly, the slope of this line is this, which is equal to this. So at this point is the efficient point. So he will produce this level of X and this level of Y, given that technology is fully utilized. So this was the concept of PPC in the production equilibrium of production. So this was all from today's class. In the next class we will discuss about equilibrium in production. So thank you guys for watching, and keep asking your doubts in the comment section. I will be happy to help you. Okay guys, thank you guys.